Actually, there was some technical glitch, and means Narang sir were not means able to connect with this session again. So thank you so much, sir, for your valuable and enlightening talk. And then after, in this momentum, we about this sustainability, we have with us Sri Anurag Bajpai ji. I welcome you, sir. Sir, you need to unmute yourself.
Yes.
Yes.
Thank you very much, sir, for the introduction and for the opportunity.
I need to introduce again.
Okay, sure. Thank you very much.
Yes. We have with us Sri Anurag Bajpai ji, co-founder and director, Green Tree Global, who is well-known veteran with his core expertise in energy efficiency implementation. So I would like to mention here that Haryana is the first state in our country to incorporate the green efficient building material, electric items and solar water heating systems in Haryana Scheduled of Rates to implement energy conservation building codes in the state. And this role of energy efficiency and renewable energy has been assuming increasing significance in recent times with a growing concern for the country's power security. So might be this term and this concept will be new for us. So we have with us Sri Anurag Bajpai ji to make us aware and enlighten us about how this energy conservation building code can be implemented in Haryana. So without further ado, with lots of requests, I'm pleased to introduce Sri Anurag Bajpai ji as our eminent speaker to address the participant in this session. So Anurag Bajpai ji is the co-founder and director and also the head of sustainability division at Green Tree Global. And Anurag sir is has an extensive experience of 14 years with core expertise in energy efficiency implementation. And he has previously worked with Siemens Power, USAID Eco 3 project. He holds a bachelor degree from the Indian Institute of Technology, Roorkee, and PGDM from IMT Ghaziabad. He also worked with assignments including working with the Bureau of Energy Efficiency, NTPC, BHEL, CPWD, WI, USAID, UNDP, CLASP, PWD, NBCC, SDAs, railways, and metro, etc. He is a certified measurement and versification professional, CMPV by AEE, and a certified GRI HA evaluator, IGBC-AB, and ECBC expert empaneled with the Bureau of Energy Efficiency. And he also served as a board member of International Building Performance and Simulation Association and a member of core committee of ECBC, SOCHM GEM, GRIHA, IGBC, FASI, and SEAMS India. So with this brief introduction, I welcome you, sir, and request you to please address the participants.
Thank you very much, sir. I would also like to congratulate JC Bose University to start this novel idea in terms of having a knowledge series on diverse subjects. So we understand that we have the students and the faculty members from environmental science and civil engineering, and we really need to look at the integration of these two aspects where we talk about the buildings and infrastructure. We surely need to look at how, when we construct those big size bridges, metro pillars, or metro stations, railway stations, and etc., how we need to take care of the environment by and large, because this is something which is very, very important aspects, not only from the Indian perspective, where we look at a lot of issues in terms of energy consumption, in terms of pollution, in terms of degraded air quality index in the towns, even the second tier towns like Hisar, Zeen, or Gurgaon, in any case, is one of the worst city in terms of pollution index that we see starting from, let's say, maybe I think September till November. As of now, since there's not much of the traffic, we don't see much of the noises. But earlier years or previous years, we have seen how much hue and cry that had happened because of the issues. So we really need to look at these aspects very consciously in international scenario where we work in not only, let's say, neighboring country or South Asiatic country, but when we look at the Europe or US and other countries, this is one of the most important topic at this point of time. And we also look at the opportunity in this segment because whenever there is an issue, whenever there is an opportunity, I'm sure like there is an opportunity for all the segments, including an education segment, in let's say, then students, the job opportunities, the research opportunities, and the startups opportunities. So there is a holistic approach that we all need to look at simultaneously, not only for the students, but I think the faculty members and even the entrepreneurs like us as well. In our subject area where we have been working for last over a period of decade time, energy efficiency in buildings. So that is the area where when I started my career after college, worked with Siemens in terms of power plant. Then we worked with the policy, energy policy domain. And then onward, we realized that there is an immense potential in terms of energy efficiency part. When we started this company in 2009, there was not much of the issues in terms of the policy interventions or even the implementation side from the buildings in terms of green building ratings, energy efficiency point of view. But currently, after a decade period of time, when we look at the journey, we see a huge potential as of now for all the segments, for all the people, all the fields need, not even only for the building designer, but I think civil engineers, environmental engineers, mechanical, electrical, all of them are required for this particular field. So I think the next time what I will also suggest that you can also include more number of, let's say, departments in this, because in case if this is online, we must utilize the infrastructure, because in case if we have 95 or 100 people, we can always have 500 people in the, and then only I think we can certainly be participating to the bigger cause, and we believe that through this participation we'll have more benefit to all. And in case if during my presentation, in case if you have any issues, not only during the presentation but post also, you can always reach out to us. Thank you again, JC Bose University, Mr. Somveer, and other faculty members for the opportunity. I'll just share my screen to start the presentation. So is my screen visible?
Yes, sir. It is quite visible.
Oh, great. So still, I would say not many people do know about energy efficiency codes and standards that have been built for the buildings or the infrastructure by and large. When we look at the buildings, we surely look at the household or our homes primarily, because this is one thing which we can always connect and correlate. And then we start with our school or college, and then go beyond to the offices and university campuses and data centers, factory buildings, and so on. And that is where we see a lot more potential in terms of energy efficiency, because most of the cases when we look at our home, we spend the electricity in terms of running a lot of appliances, and at the end of the month or couple of months, we pay the bills to the discom. But in most of the cases, when we do that, we really don't uh, care much until unless the bill comes too high. In case if your regular bill is coming, let's say 500 rupees or 1000 rupees, in case if you get a bill showing, let's say 10,000 rupees, then only you will realize that this is something which is pinching you. Otherwise, you don't care much. So that is where we see your attention, that whatever is coming to your way, it is really important you to analyze it, whether you have the potential to reduce it. And in case if you don't care it, I'm sure like the bill will certainly be increasing day by day, and this will create a, a major cost consumption on you in case if you are running the building, you are running the university, or running the factory, or the whole set of other activities for your business. You can also check in your university whether the bill must not be coming, maybe I think less than less than 10 lakh rupees per month. So that is where you see a lot of electricity consumption which is there, and that is how the government of India has also taken the initiative in terms of how we can reduce or optimize the electricity consumption of the built structure. Now, this is something which is very much important from the climate point of view, how it is related, because the moment you have the optimized kilowatt hour or kilowatt or your electricity consumption, it will be a direct impact on the demand of your power plants. The less demand of the power plant will certainly be requiring less coal consumption. The coal consumption reduction will certainly be an effect or impact on reducing the carbon dioxide or so many other hazardous, the gaseous outcomes which are a part of the electricity generation as well. So that is where we see a lot of things which are interconnected. We talk about the carbon neutrality, carbon reduction, and so many other aspects of the built structure, not only the buildings, but also, let's say, from the automobile and other segment as well. But this is something which is very much important aspect in terms of how we can optimize the electricity consumption from your running bills. And this code which gives an impetus in terms of saving of almost like 30 to 40% of your electricity bill. But how we can just take it through, and then we can have the questions at the end of the presentation. Energy Conservation Building Code, this also has, and let's say, the correlation with the green building norms. But in terms of the code, it started in 2007 by Bureau for the Efficiency, which is a regulatory body of Ministry of Power. And then we have a second version, or the second launch of the code in 2017, which is almost like a decade later. I'll describe about the scope, the technical specifications, and then the compliance option for the buildings. Then we also have Eco-Nivas Sanhita, which is meant for residential buildings. So the first one is commercial building, second one is residential building, and then we also need to look at the levels, how we can improve in case if you are saving 30% of the energy, how we can go to 50% and go to 70% and onward. So there are levels which have been also laid by the government, and then motivate at least the major stakeholders in terms of making it more convenient to the user in terms of comfort conditions, along with the reduction of the electricity consumption in the. So in terms of the code, it's primarily governed in three components. One is the scope, which talks about how much connected load the building has. For example, in case if you talk about your home, your home must have the connection of either 1 kilowatt, minimum 1 kilowatt is required, and then 2 kilowatt, 3 kilowatt, or 5 kilowatt. When you talk about a lot of, let's say, the bigger houses, they also have up to 10 to 20 or 15, 20 kilowatt as a connected load. In some of the cases, states, they have the measurement in terms of kVA. So when they measure in kVA, they certainly look at their savings. So discounts will be benefited in case if they measure the bill in kVA. In case if the kilowatt is the measurement, then certainly they talk about the consumption which is at your end, not the losses at their or discounts end. So from the scope point of view, it is mentioned as the connected load. What is the minimum connected load of the building, so that the building can come under the scope of your code. So not all the buildings will be the part of it, but some certain minimum threshold which has been mentioned in terms of connected load and contract demand of the building. And then in case of the built up area of the building is more than certain square feet numbers, then also it will come under the scope of it. Then it has a minimum efficiency standard for all the component. When we look at the university campus or your home, you also need to look at the first part is your civil construction, which includes the wall, the glazing, the windows, the roof, that we call as an envelope. Then we have air conditioning systems, then we have a lighting systems, and then electrical power, the renewable energy. It's primarily the supply side of the equipment that we talk about. Then we have a compliances. So generally, when we look at the regulatory compliances, we talk about, let's say in case of Haryana, we have a HUDA, Haryana Urban Development Agency, which has the responsibility to provide the sanction of your buildings. So once you have the approval from the HUDA, you can construct your building. Otherwise, you will not be able to construct the building or the university campus. So there is a compliance requirement in terms of prescriptive and then the whole building performance approach. So based on this approach, I'll explain it what they are, and then you need to submit it along with the maps, and then your submissions will be reviewed, and then you'll get the sanction of it. This is the scope specific. So the buildings which have the connected load more than 100 kilowatt or contract demand more than 120 kilowatt, they will be the part of the scope. Or the third component, which is the built up area, it takes the plot area 1000 square meter with a minimum 2000 square meters of built up area, they'll be also counted. I believe that civil engineering background people can correlate the third component easily in terms of the square feet on the plot area or the built up area. Now, some of the other buildings which will be also the part of it, for example, the university campus, which is going for the extension. So the extension building or the new building, which is going to the part of the campus, and in case if they follow or cross the minimum benchmark meant by the code in terms of connected load and the contract demand, they'll also be the part of the compliance requirement. In case if your particular building, which is, let's say, for example, this is a chemical lab, and you want to convert it to the, let's say, the studio or the classroom, then this is a major retrofit, because in case of lab, there's a lot of exhaust, fumed pipes and other ducts and etc. They'll be the part of it. When you talk about the classroom, then you have air conditioning systems, which will be the part of it, and so many other things. So in case if you do the major retrofit, then also compliance requirements are there. Now, being the civil engineer or the environmental engineers, you can always understand the life cycle assessment component of the building. So, for example, your building which you construct and design, it runs for 50 years minimum as per the codes. And if you could maintain it well, it can run also up to 75 to 100 years as well. We also have seen the buildings like Taj Mahal and so many other, let's say, Jaisalmer and other forts, which also have been there for last 300 to 400 years so far. So that is where we see the maintenance quality and then the structure stability, which defines the life cycle of the built structure. But from the civil point of view, it is okay. You can always make the structure, the column beam structure more strengthened, and you can always increase the life cycle. But in case of the running it comfortably, how about the life cycle of the air conditioning system, lighting systems, let's say fan and etc. So there is also a life cycle association or associated for those equipment as well. For example, your air conditioning system which you buy from the market, let's say this is a split AC or window AC. All of you must have seen this system at your home. the life cycle of this is not more than 10 years. You can't run it more than 10 years. Most of the cases, the technology comes into the picture, and then when you have a more efficient system, after 5 years itself, people tend to replace it. But you can run, in case if you really want a system to be running, the life of the expectancy is 10 years. Now, with other systems in terms of air conditioning itself, there are, let's say, air cooled chiller system, water cooled chiller system. They have a life cycle of 25 years also. So based on the design of or the usage of the building and the size of the building, you need to design or select the system and which can be go along with your life cycle of the building as well. For example, in case if you are running let's say a university campus like yours, and you realize that most of the cases the usage of the building is not going to change for next, let's say, 10 to 15 or 20 years, you certainly need to have the best efficient system which has the maximum life cycle, so that the replacement cost or the maintenance cost can be lower down, can be optimized. So that is where the usage of the building can also be the defining factor, and can give you the information that what kind of system that is the requirement for you to make the building more optimum in terms of the maintenance, and also give you the required comfort conditions. In this particular minimum efficiency standard that is a part of the code, they talk about the minimum efficiency standard for the building envelope, then air conditioning system, for lighting system, for electrical, renewable energy system. So all these components, they have been a part of the code in Haryana also. And then it has been mentioned that they need to be followed, and the building owners or the architects or engineers, they have to follow and adhere to the minimum efficiency standards. We call them as MEPS, minimum energy performance standards for the code. What are those? Instead of putting up the numbers, I have tried to put, let's say, make it more picturesque so that you can correlate it easily. For example, the code has an article or the section 4, which talks about the envelope performance standard. In case of envelope, they talk about the wall specifications, the roof insulation specification, the glazing specifications primarily, and certainly the orientation and shading. So this is where we look at these two examples. So one, you can see the very, let's say, the contemporary facade design, where the color is entirely stark red color or the maroon color, and the design is also not conventional. You can see still the glazing there's an opaque construction, and then there's a design aspect in terms of the orientation of the facade. Now, in the next to this slide, this image, there's an image which talks about the facade only, but it is designed very differently. It has a very conventional set of design, column beam structure, and then you have a windows which are recessed in nature, which can certainly create the shades properly. And then it will certainly be an important aspect, while the sun, which is, let's say, at the situation where the sun radiations are coming directly to your indoor spaces, then such let's say shading devices or the component of the facade design certainly help the building in terms of optimizing the heat gain. And that is where we need to look at the designer's perspective. The designers means the people who are like you, the civil engineers, the environmental engineers. You can always help the architect or the designer or the owner of the building in terms of optimizing the heat gain through the proper orientation, or let's say having the less glass in the worst directions. For example, in case if you look at your home, in case if your home has the front window facing west, you will certainly have more heat inside of the space. You will not feel comfortable when you go back to your home after, let's say, 3 or 4 p.m. What is important? not having the window in those direction, or at least the less amount of windows in those directions. We can always have more windows in the north, east and south, so that we can have the diffuse sunlight rather than the direct sunlight inside of the spaces. So that's sort of, let's say, the common logical interpretation that we need to have, and the code also talks about the same thing. So that is where we see the education, which is, let's say, from the university point of view or from the school point of view, is really important to tell a basic thing which are logically correct, and you can always correlate them while take an example of your university or your homes as well. Now, coming to the next part in terms of wall and roof insulation, you must have seen a lot of buildings with the red brick structure, and you also have started seeing it in terms of the newer material like fly ash bricks or autoclave aerated concrete bricks, or you might have seen the insulation as well, some insulation on the rooftop also. So why do we need to change from the red brick to this brick? Because this kind of brick structure or the brick material has more resistance to heat, and they can always help the buildings to avoid more heat gain from outside to inside the spaces. So these are like the basic thing to understand, and then in case if you could advocate and propagate further, you'll certainly save a lot of energy, and certainly in case if the energy is saved, it is the amount in terms of the currency that you can always save for yourself. This is the insulation material that is like the, let's say, uh, within the wall, let's say, if it can be outside of the wall, it can save more energy. In case if it is inside the wall, certainly it will save some energy, but not as compared to outside of the wall placement. But the insulation, the purpose is to resist the heat from outside to inside. Then insulation material or the paint material over the rooftop, we understand the radiation fall, which is the maximum over the horizontal surface in our latitude, and that is where we see a lot more naturally selective or adopted usage, like in case of Jaisalmer or in case of Dharavi. A lot of, let's say, the smaller set of houses, they have started using it as a blue color shade or the light shades. Why do they do this? This is not something that they need the appreciation from the visitors or the guests coming to their houses. No, because visitors is not going to appreciate the roof color. But this is like the basic thing that we need to understand, that in case if we have the roof color which is lighter shade in color, it will save the surface in terms of absorbing more heat coming from the infrared component of the sun rays, which is coming directly from the sun. And in case if it can be reflected back to the atmosphere, that will certainly be a lot of help uh, to the building owner in terms of avoiding the sun rays and eventually the heat inside of the space as well. So it's very much important, but now there are a lot of, let's say, the paints available which can help doing this. And then talking about the glazing, it certainly is very, very important aspect of the construction. It costs you a lot when you talk about the material cost. You must have seen the single glaze windows, the simple thin 5 mm glazing in your university campus or at your home. But when you look at the big office complexes, they use the thick windows. We call them double glaze windows. So they have two layers of the glass, and in between there is a argon or neon gas filled or the vacuum as well sometimes, to make it more resistance to heat as a characteristic of the glass component. So they have more glass in the facade, but they also resist a lot of heat inside of the space as well. So that is something that we need to know, that there is a high performance glazing available, and the codes recommends to apply them in case if the glass component is more in the building, which are, let's say, commercial in nature. And then this is our typical way of, let's say, representation in terms of, in case if we have a 4 mm glass, then it will allow more heat inside of the space. In case if you have a better glazing, and then it will allow less heat inside the space. Then whatever is the indoor environment that we have, either in case of your home or in your university, we talk about the diffused light rather than the direct sunlight. So direct sunlight creates a lot of glare. We need to avoid that. This is a discomfort compared to the visual comfort conditions requirement. So we need to look at the glazing placement and other such projections, which can help in terms of letting the diffuse light inside of the space rather than the direct sunlight. This is one of the projects that we have done in Haryana. This is Fortis Institute, Healthcare Institute in Gurgaon, and look at that sort of, let's say, the design analysis that we did for the project. You can see the kind of, let's say, the skylight that is a part of the build structure. And from 6 a.m. to 6 p.m. in the evening, there is no such artificial lighting which is required for the project. And you can see a lot of people, they are sitting comfortably and they are talking, they are reading, they are writing as well in the lobby area, because they certainly are the relatives or the acquaintance to the people who are hospitalized there. So that is where we see a lot of, let's say, the energy saving out of the natural sunlight available. These are the requirements or the calculations that we see, which is which are mentioned in the code. So it says that the unified, the useful daylighting index, which is required for a particular building category. So for the educational campuses, minimum 40% of the daylight which is required, and the daylight level is 100 lux level in almost like 90% of the time throughout the year. So that is something, there are tools available which can give you this calculation, and there are methods which you need to know, and there is so much job requirements also for students and the professionals having expertise of doing the daylight and energy simulations in the market as well. Then the comfort systems like air conditioning system. I did mention that kind of systems that are required at different kind of buildings. And then in case if we could use the natural conditions in terms of natural ventilation methods or the mechanical ventilation method, it is always like the best case scenario for the building, because you are using less electricity in terms of running the compressor based cooling systems. So that is where we see a lot more due diligence which is required from the engineering background professionals in terms of making it more optimized for the owners running it in the lesser cost. Other passive technologies which are also the part of the systems, people have been doing it for several number of years. Even in case of Haryana, there is a university near fort. I don't remember, I think the location, but there is a university, I think this is, which is also using the earth air tunnel for the hostel blocks. And during the night time, it uses all the passive cooling measure to make it more comfortable for the students who are spending time during the night time, and they don't need to run the air conditioning system during the peak summer as well. So there are technologies which are available. There are universities, campuses which also have used such technologies. I also recommend to the university stakeholders as well to just explore some new technologies, showcase them, so that the live lab sort of setup can be established in the university campuses, and the university and the students can learn from them, because that is something which is very much important for them to learn and be ready for the market to get absorbed for the corporates. Then coming to the electrical component, this is the last section of the code which talks about the supply side of the equipment, be it the transformer efficiency, the load losses, the DG set efficiency, or the capacitor bank, power factor, and so on, metering, monitoring. And then we talk about the generation side in terms of renewable energy generation. It is building integrated, but from the code side, it is not talking about the BIPV, but talking about solar PV generation side for the campuses or the commercial buildings up to 1% of the total connected load in the campus, as per the Haryana state. These are the compliances required, and showcasing the methods. These are the tools which can generate such thermal tools, and then these are the calculations through which it can be shown that the whole building performance is better than the base case performance set by the code and standard, and they are the part of the submissions in the HUDA as well as of now. They are the few of the projects that we have done in other part of the country. And then talking about the residential, it's also huge market coming in years, because when we look at the let's say the numbers in terms of built up area which is available in urban location and in the rural location, you look at the 2020, which has urban built up area is almost like 5.9 billion square feet, which is going to 22.2 billion square meter in next 30 years, almost like 4 times. And then 11.8 billion square meter in 2020 as a rural built up area, going to 25, almost like 2.5 times. And that is where we see a lot of opportunities in the residential energy efficiency market in going forward. But there's a segment which has been anticipated, and the Bureau of Energy Efficiency has already launched a lot of initiatives in terms of optimizing the let's say energy consumption optimization for the residential building sector. So first initiative is in 2018, named as Eco-Nivas Sanhita. They have also launched a label for residential energy consumption, and so there is a provision, let's say in the ENS 2018, we call it in, let's say, Eco-Nivas Sanhita 2018. And then the only envelope section, the civil component section has been shown at this point of time. The rest of the component in terms of electrical, mechanical, they will be integrated later. But at this point of time, when they talk about what is the minimum natural ventilation system, they have to be there in terms of operable windows, floor to area, window to floor area ratio with respect to the climatic zone. Then they also talk about the daylight, the heat gain and losses from there. So in all these, let's say the measures, they are there for what is the, I'm sorry to interrupt, but what is the time that we have? So Virji?
Sir, we have time, means you can extend 5 to 10 minutes might be.
Okay, sir. Okay, sure. Thank you.
So time of this session is about 1:30, but you may take your time, sir.
Okay, sir. So we also, from the policy perspective, because we've been working with different governmental and intergovernmental agencies as well in India and outside India as well. So when we also look at the let's say the policy path which is today and going forward, the way the India is moving with respect to the commitment to the let's say carbon neutrality commitment to the global forums. They talk about the net zero concept and in going forward. Also, let's in terms of, this is a typical standard where we see the typical built up area in a particular commercial building. They consume 1 square meter of those built up area consumes almost like 220 to 25 units in a year. And then we talk about the ECBC compliant building. This is Haryana state ECBC compliance I'm talking about. Then it's almost like 30 to 35% or 40% reduction from this, let's say, the level. And then we talk about rating or rated buildings. Then we talk about further reductions. And then we have a policy framework which is talking about the net zero component also. So what it particularly means that whatever you generate, whatever you consume in terms of electricity in a year, you are supposed to generate it annually through the means of renewable energy systems. And that is where we see the role and responsibilities of the policy interventions, and also certainly the support from the government, not only in terms of the policy support, but also in terms of incentives. So at this point, in the current situation also, the Haryana state is giving a lot of incentives to the building owners, be it the university or the let's say the commercial building owners, in terms of the incentives, who are going for compliances, who are going for the green building rating certifications. So in the typical practice of designing the net zero energy building is, you start the building, the consumption is higher. It's almost like 1 square meter consumes maybe, I think, close to 200 units. When you do the design with respect to the passive cooling measures, it can dot it down to 120, 125. And then you actually have an intervention in terms of making it more efficient through the use of better equipment in the building. You can always make it to 50, and then you can always compensate the rest of the power requirement from the solar energy side. So that is the strategy, which is not a rocket science, but it is a simple logic driven strategy which you all can understand well. But this is something which is very, very much important. Why am I saying that? Why India is moving towards net zero? Because a lot of cases, when we look at the Western countries like Europe and US, we see this trend that in case if something has happened there in 10 to 15 years down the line, we also need to look at the same sort of set of path and activities in Indian market as well. We certainly are progressing. We are growing with a faster pace, barring the current pandemic situation. But still, there's a lot of things that have been all done in different countries, and we believe that there's a lot of opportunities in this particular domain will come because of the aggressiveness from the Bureau of Energy Efficiency, or from the policy point of view from Ministry of Power in this case. Few examples, like this is net zero energy building in Singapore, this is US, this is in Delhi. You all can visit. We can also help the students in terms of making a tour from for the university. This is MOEF building. There are a lot of people who are coming. I'm sure, like the university faculty members and stakeholders, they must be knowing about the building as well. So it has almost like 1 megawatt solar panel installed over the rooftop. It's almost like close to, this is your own building in Panchkula. This is Haryana building, Haryana Renewable Energy Development Agency. We also are running our energy conservation building code ECBC cell established there. We have one architect and a couple of engineers. They are sitting and assisting the state machinery in terms of implementing the code and standard in the Haryana state. And this building, if you go inside, you can see this technology where this has mist coming in this courtyard during the afternoon period, so that the more humidity during the peak summer time can create more comfort condition inside of the spaces. And that is also one of the more building that we see. We are also part of the design consortia. There, this is Uttar Haryana Bijli Vitran Nigam in Panchkula. This is again the net zero energy building supported by USAID. This is a university campus in Rajgir, Bihar. This is one of the most renowned university centuries ago. It is named as Nalanda University. Now, the new university campus, it is getting built in the same name, and we are a part of the design team. And this university is not only going for net zero energy, but also going for net zero waste, net zero water. Even you can't believe it, during the construction phase of this university, which is going on at this point of time, it is not using a single drop of water coming from the municipality. They are using all the water from the rainwater harvesting. They have created the large pool of ponds, and they use the pond water. They store the rainwater during the peak monsoon and the annual monsoon period, and then they keep using the water rest of the year in the construction. Amazing case study there. Is it really useful? I think this will certainly help you when you go to the market and you understand what kind of knowledge that you have. It will certainly help you a lot in terms of making you industry ready, in terms of job prospects, in terms of your own startups or venture aspects as well. Some of the examples, they are there already. You can always make a tour. This is one of the buildings which is ECBC compliant. You can always see. I'll just take you through the specific slide. This was the conventional design component of the material which are there before the building was about to finish the structure. And then this is how we got involved in terms of creating the options for the building. So this building owner is UPERC, Uttar Pradesh Electricity Regulatory Commission. So they realized that this has a lot of potential in terms of ECBC compliance and the green buildings. So they asked us to submit the proposal in terms of the options. We submitted these options, that what are the technologies in terms of wall, roof, the air conditioning, lighting, renewable energy sections, and glass. So all these things, when you create the options, you certainly require certain expertise in terms of the simulations tools and the software, and then you can calculate the savings based on the inputs that you put in the tool. So 51% can be achieved in terms of energy savings based on option 1, 41 and 40 and 35% based on option 2 and 3 respectively. And that is how you can always create the options compared to the base case, and you can always calculate the savings based on the cost saving I'm talking about, based on the cost investment on different component of the building which you have proposed in terms of option 1, 2 and 3. And you can always calculate the ROI, because whatever savings that can be achieved and the investment that you have put in today's date, and saving is recurring. So it means that you need to calculate the number of years which are supposed to be available for you to get your investment back, and then 4.6 years onward, because the building runs for 50 years. So 4.6 years, in case if you just remove this, then rest of the life of the building, you are just saving the electricity for yourself or for your money savings. So that sort of, let's say, the simple collections can always make your client convinced that this is how you can always proceed, and you can always go ahead. You can always send me the email. I can share this presentation with you all so that you can have an understanding, to understand the technology part, to understand the ECBC code requirement in more detail. Further, in case if you have any question, you can always write me on anurag@greentree.global. And with this, I'll close my presentation. Thank you very much for the patience listening, and thank you for the opportunity, sir.
Thank you so much, sir, for this interesting and enlightening talk on discussing very insights of energy conservation for domestic as well as commercial buildings, starting from this envelope designing as well as supply side, and even the generation of this green energy or renewable energy. That certainly help us to reduce the emission and also to control the climate change also. And you rightly gives us example from the national as well as domestic sector also, to give a insights about that how we can reduce this emission during the construction of buildings also, and can reduce the energy consumption. So with these words, I think we may attain some of the questions, sir.
Yeah, sure. Why not?
Okay.
Do you have any question?
Yes, few of the participants, they asked some question. One of the participants, Monica Rani Verma, she asked that what are the other initiatives by the government to curb this emission from the building sector other than energy conservation building codes for energy efficiency in commercial buildings?
Yes. So, Monica ji, there are several initiatives by the government, even by the state government as well. For example, when you look at the buildings, energy conservation building code is one of the requirement which talks about the holistic energy efficiency component for the building. But for, let's say, when you look at the bylaws integration, it talks about all kinds of let's say suggestions or mandatory requirements. For example, renewable energy component. So in case of Haryana, it asks you to have minimum 3% of the connected load to be installed over your rooftop or to your building premises as a renewable energy. In case if you're building a residential development, then minimum 40 kilowatt peak as a connected load is required for the residential group housing projects. And apart from this, it talks about the rainwater harvesting component, which is mandatory. I believe that so far there's not much of the implementation on ground, but if you look at um, the consciousness among the stakeholders now, people have started doing it religiously. Then other component with respect to the minimum grass area compared to the tree plantations, there's a lot of, let's say, the changes that you must have realized so far. Even the participations from the corporates which are there, for example, Jindal Steel or Havells factory, a lot of let's say these corporates, they have also been asked by the government to pick up the area, and they can always have something related to the environment in terms of energy efficiency, or in terms of rainwater, in terms of pollution reduction point of view. So all these components, they have been the part of the government initiative in this case as well. We also have a very strong environmental impact assessment committee in the state of Haryana, which talks about the initiatives with respect to the environmental protection point of view. And all the buildings, when they start going for the map sanctioning, the first step to get the environmental clearance from this committee as well.
Thank you, sir. Sir, means you talk about this implementation of energy conservation building codes in the built environment. So can it be possible to adopt in already built environment, means such kind of buildings which are already built? So can we implement this codes there also?
Yes, so certainly when you talk about the new buildings versus the existing buildings also can be adopted for such compliances. And there is a specific way of doing it. So you need to do the IGA grade audit. What it means to say that there is a specific requirement of assessment of all the equipment and all the civil structure of the building. When I say civil structure, not from the point of view structure stability, but also the point of view from the envelope component. So in case if we don't have the let's say the SRI paint or the insulation over the rooftop, we must look at this aspect. In case if the glazing or the windows which are there, in case if it is a simple glazed windows which is allowing more heat, we need to have the films which are available, not very costly also, but it will certainly create a wonder in terms of creating the comfort condition inside the space as well. So they are simple measures, but they can be applied and implemented in the civil component or the envelope component of the building. And then we certainly need to talk about a lot of, let's say, the fan, light, air conditioning system, DG set, renewable energy systems, transformer losses, the switch gear component in case if it is a part of the bigger campus. So a lot of, let's say, the component, they are there as a part of the campus or part of the built structure. We just need to assess them, evaluate it with respect to the life cycle, with respect to the issues on the energy saving point of view, that what is, whether this is required a retrofit or the modification in the component, or do we need to require the replacement. Sometimes when you look at, let's say, the fan, which is very old, let's say 10 years old fan, no matter what is the rated capacity of the fan, because it should be as a 50-60 watt, but it might be consuming almost like 100 watt. Yeah, so that is the draw power that is required, because just because it is certainly having a lot of, let's say, the bad capacitor installed in the fan. So that is sort of, let's say, the initial level of feasibility or the evaluation is important, and then you can always decide what to retrofit and what to replace, and then going forward you can always calculate what is the amount of let's say the investment, and then what is the ROI. So this is something which is an important aspect going forward. And there are a lot of campuses, a lot of, let's say the offices, they are going for this aspect because electricity is really, really going to be very costly aspect and affair.
Thank you so much, sir. Sir, one of our participant, Abhay Prasar, she want to know about Canada buildings for the innovative, sustainable design.
Mhm. I'm sorry, can you just say again, sir?
He's asking about Canada, KENDEDA, Canada, buildings for innovative, sustainable design. So he want to means he want to know about this.
CA and Canada. You mean the country name or
KENDEDA.
KENDADA?
DEDA, Canada.
Okay. So maybe I think I'll request you to just uh, send me the email. I really don't know about it.
So there is no other question in this chat box. So I think means we can mind this session. One more question is there, sir. What are the some measures or steps in buildings for low carbon strategies?
So, yeah, so I think the major I think the main steps that we see as I started with the envelope component first, then we need to talk about the comfort systems, air conditioning component, because envelope is something which is the long term in, let's say the interventions are required. The second component, air conditioning system, because it consumes almost like 50% of the electricity from the generation side. So comfort systems are the second priority. The third priority, which is the lighting and the fans. Lighting is very simple measures to replace it. You must have also seen the replacement of the lights and these fixtures in your in city campuses also, or even at your home. You must have been seeing the usage of incandescent bulb, and you must have gone to CFLs. Now you have started using the LEDs. So this is like the simple measure, which is very easy to understand in terms of when you replace this from this, you can save this much wattage or this much energy. So this is like the most simplistic step. So this is the lighting component. And the last but not the least, I would say the supply side of the equipment. So for the home, it might not be a major issue because most of the cases supply side of the equipment are being supported by the discoms only. But for the bigger campuses where you have the switchgear yard as well, you have your own transformer, you have your own DG set as well, you have your own distribution system, uh, the the panels, the meters, and everything that you have within the site, then certainly the supply side of the equipment important. They play an important role in this. So I think this is the priority-wise steps, and we need to follow them while assessing or optimizing the energy consumption of any built structure.
Thank you so much, sir. Means thanks for addressing all the questions. We are not having any other question from participant side. So I would like to invite Monica Mago madam to propose the vote of thanks. Monica ma'am is there? So thank you so much, sir, for your time, for your contribution, and for this informative and interesting talk. And you have covered almost every part of this energy conservation. And thank you again a lot for making this session more interactive and more informative. Thank you so much, sir.
My pleasure, sir. Thank you very much, all of you from JC Bose University. It's my pleasure, and look forward to seeing you all in person. I believe that this has a greater potential of interaction in terms of sitting at your home or at your offices. But I think nothing can replace your in-person experiences in times to come. So we all. Looking forward to meet you all, and all the very best to have a great and best future in your life. Thank you very much.